So in this video we're going to take a look to the plugin making calculations to identify pairwise interfaces in large complexes involving several subunits. So I go to the plugin menu of VMD2 SBL and it's called Interface Finder. So this is popping up the window with the options of this executable, and of course the main option is to select the file containing the example to process. So here I'm taking a model of the proteasome PDB ID2H6J, and I'm going to launch the calculation. So this is a big file which is involving more than 20k atoms for a total of 14 subunits. So as you may know, the proteasome is a barrel-shaped structure with 7 unit rings, and in the VMD output here we see 2 such rings. This is a side view, and of course on every ring we find these 7 subunits. So if we take a look to a specific edge of this graph embedded in 3 dimensions, for example the edge between C and D, we get 2 numbers. The first one, 156, tells us that at the interface between chains C and D we have 156 atoms, and the second number, 3, tells us that these interface atoms are distributed across 3 separated patches. So the interface model here is a so-called Voronoi interface model. In fact, it is computing pairwise contacts between balls restricted to their Voronoi regions. There is a specific package doing this calculation. I refer you to the user manual of this package and also to the movie presenting the associated plugin. So of course in the VMD menu we can now display the subunits themselves. For example, I'm going to show chain C here in gray and chain D here in brown, and so the numbers we were looking at are again encoding contacts between atoms from these 2 chains. And of course you can do the same between any 2 chains. For example, at the bottom here I can display the contacts between N and H. So chain N here and chain H there, right? In green on the right hand side and in purple on the left hand side. Alright, so if we now move to the main window of the plugin, we have several pieces of information. The first one on the left hand side is a 2-dimensional graph computed or displayed with graph viz, which is in fact again displaying 1 node for every such unit, and in fact 1 edge for every contact. And again we can take a look to the examples we inspected earlier, for example D and C, and so this is the edge D and C, 156 atoms distributed across 3 patches. On the right hand side we get a different graph and as you can see here we get 7 subgraphs. In fact it's here a bipartite graph somehow. And in fact this graph displays so-called biochemical interfaces, and in particular we are computing the salt bridges and disulfide bonds found between subunits. And here as you can see we get in fact 1 salt bridge for pairs of subunits, and we have 7 of them because of course each ring is involving 7 subunits. As I told you at the beginning, so we have here a specific directory to host the output files, and so we can go there and inspect what's going on. And so if I list the file, we see that we have a log file recapitulating all the calculations. We have a dot file which is a graph file encoding the 2D graph. We have the VMD file corresponding to the structure sent to the 3D graphics engine of VMD, and finally we have XML files corresponding to the records associated to pairwise interfaces. Naturally one can exploit these XML files by coding, exploiting using Python parsers.